Hello everyone. Today my team and I will explain to you about tNavigator software, which we will cover about how to drill producing well and how to drill new injection wells and how to drill new horizontal wells and how to convert from producing to injections. For example, we need to drill new producing wells in 2012, which I must have well space, comp data, well control producing. The well space, it's introduced the new well, which include the name of the well, the name of the group, by location, geolocation, and one start is the default of the reference depth of the bottom hole pressure, the oil its preferred phase for the well. The comp data, it specific the position and properties of one or more well completion, which include the name of the well, I location, geolocation, the key location of the upper connection block, the key location of the lower connecting blocks. It's about here open or shut, which is open because we need to produce oil. The two star is the default of the saturation table number for connection, relative permeability and transmissibility factor for the connection. 0.625, it's the wellbore diameter. 1 star is the effective permeability volume, and 2 it's the scam factor. The well control producer. The well control producer, it's controlling our new producing well, which include the name of the well, it's open or shut, which of course open we need to produce, related, which group related in, the 3 star, it's the default of the oil, gas, water rate target, 7,500 the liquid rate target. 1 star, it's like we have no target for our reservoir fluid volume. 2,250, it's the bottom hole pressure target. Let's say run this code in our program, which our software. First we need to save it and open our tNav and run it. As we see here, like in 2012, our new producing start, which is here in cell 9 by G8K1. Thank you. I will let you to my friends to continue.
I will discuss today on how to drill new injectors in the tNavigator. The first keyword here is the well specs. The well specs is introducing a new well and the position of a wellhead and the bottom reference depth and other specification data. Here we have in coding, we have 5 items. The first item is the name of the injector, the location of the injector, the X and Y where I need to drill my injector specifically. My default here is the depth for the pressure, the bottom hole pressure, and the kind of the injection, which is whether gas or water. My second keyword is the comp data, which specify the position and the properties of one or more well completions. This second keyword must be entered after the well specs. I have here 11 items. The first item is the name of the injector, My default here is the X and Y. From 1 to 12 is my layers. The open is the flag of connection, stated here open, which means the connection open to flow. The second default here is for the relative permeability calculated using the same saturation table. The 0.625 is the wellbore diameter. The third default here is for the effective permeability. 1.5 is my skin factor. The third default here is for the transmissibility factor using the remaining data in this record. The last thing here is Z, which is my direction. Last but not least, the third keyword is the well control injection. Here we have 7 items. First of all, the injector name, the type of the injection, the flag of connection, the rate, and the amount of the rate injection, which is 7,500. My default here is for no limit or a target for the fluid volume. The last item is my pressure of my bottom hole. So here is an example. Will be shown on how to run and drill the injectors in the tNavigator. I'll be drilling only one injector, which is injector number 1, 725. Here, injector number 1 has been exhausted. The same location, 7, 25, and 1.
Hello, I'm Shamekh. In this part of the tutorial, I will explain on how to simulate horizontal well, how to set the economic limit data for production well, and how to group control production. The first part is the horizontal well. As we can see here, it is similar to that for vertical well, except in the completion data we have to perforate each cell separately along the x-axis or y-axis. Here is an example of the perforation along the x-axis from the grid cell 8 to the grid cell 13. When we run it in the tNavigator or Eclipse, we can notice how it looks like. Where we can see here, it is perforated from the grid cell 8, 13 to 13, 13 along the x-axis at the layer 1. It is important in some conditions, some reservoir conditions, where we need to increase the reduction of hydrocarbons and maybe reduce the water cut. The second part is the economic limit data for production well. Here the keyword WECON is set to control the production of the economical limit for the well. We can set it for separate well or a group of wells. Here we have the minimum oil rate, the minimum gas rate, the water cut, gas oil ratio, water gas ratio, and the workover control. In the workover control, it is set the action of of the economical limit. In the group control production, we can set a group of wells or the whole field to be controlled by the keyword oil rate, water rate, and so. Here in this example, we see it is controlled by field, the oil rate for 15,000 CB per day. In some cases, we will have facilities with limited storage, so we have to set the group control production so that we don't produce more than what we can store.
I will be discussing how to convert the production well to injection well. To convert it, we have to use 4 keywords. The well control production, which contains the details of the production, and the well specs. We only change the name here, we still have the same location. The third keyword is the completion data. It contains the same completion data of the production because they have the same location. Then the last keyword is the well control injection. So I will show you now an example of how to convert. So let's say I'll convert plot 3. Okay, here we have the dimensions. I have to choose which here, so let's say 2022. Here the production name, so I chose plot 3. Okay, I have 3 injections here, 1, 2, and 3, so this will be my 4th. Okay, so and we need to change the location. The location is here, 16 apply energy. Okay, and then you have to save it and reload the model, then back.
So as we can see here, we change it. So this is the injection for now. This is our injector. So this is how we convert it. And on behalf of me and my friends, my group mate, I would like to thank Mr. Benavian for his effort during teaching us Reservoir Simulation and made it simple to understand.